Okay, folks, I'm going to talk through a quick sensitivity analysis on a function that is probably different than the problem you're working on, but it's going to be kind of a neat function nonetheless. So here we are. I'm in MATLAB. I've got a little bit of code to define a function that is based on two different parameters. I've got my A parameter and my B parameter. A controls some part of the function, B controls some other part of the function. And what I want to determine is how changes in B affect the time to the peak and the value of the peak. Okay, so if I run this function with B equals 1, I can take a derivative, make a plot, look at it, and I can see that my peak is somewhere up here, and the time to get to that peak, or the x value to get to that peak, is figuring out when the derivative is 0. So the VPA solve is saying, hey, set the derivative to 0. Start looking near here, and then actually go ahead and solve, so it gives me a value up here. And then the peak height, of course, I'm just going to plug in that time to peak back into the function. The interesting thing is that when I change this value and rerun it, I get different values for the time to peak and the peak height. So this is where we start with sensitivity analysis. How do changes in these values yield changes, how do changes in this parameter yield changes in these values? In other words, how do small changes here affect changes here? Well, I have this code set up in such a way that I can rerun it with lots of different values, and I can just keep very careful housekeeping of each one of these values when I run the code, and I'm kind of measuring the sensitivity. Now I've already done this, so let's go over to Excel where I kept all my housekeeping. So here were all the values of B that I did. So I went from 1 to 5 by 0.25s. In the problem you're doing, it is likely a bad idea to do this big of a range with this big of steps. You should probably be doing smaller steps on a smaller range. But for example's sake, this is what I did. Time to peak, again in MATLAB, was the x value to get to this peak. That's where the derivative was 0. And for all of mine, they're close to 0.5, so I just let the solver look near there. Peak height was the actual height of that peak, so back in MATLAB, that's the y value of that peak. And so what I've done is I've plotted these two things, different values of B on the x-axis, and then in my plot, when I did, here, let's do this. If I were to change chart type, here we go. I can do a combo chart, and I can tell it, hey, I've got two things being plotted here. My time to peak is one of them, my peak height is another one. And then I went through and very carefully labeled all the axes so I can see all this stuff. So my time to peak is on the left, that is the blue curve, and I can see that when this thing is getting steep, that small changes in B are going to yield larger changes in time to peak. Whereas when I'm fairly large here in B, small changes in B are going to yield very small changes in time to peak. So I would say that time to peak and actually peak height are not very sensitive in this range and are rather sensitive in this range. If I've got a steeper slope, then a small change in the horizontal axis yields a large change in the vertical axis, and changes in my parameter, or I'm sorry, my output is sensitive to changes in my parameter. So I did all of this kind of in the background. I took very careful housekeeping, and there's ways to do it, so MATLAB can do some of this work for you if you want. But with what you know right now, this will do it. So I hope this helps us with sensitivity analysis. Remember, when you're presenting these results, a plot is far more meaningful than a table of values, and this gives you something to point at and talk through when you talk through your final problem.